What's good, Grizzlies? We're in the 4th week. I hope you had a great weekend. I did something for the very first time this weekend. I painted my wife's fingernails and toenails. I think I did a pretty good job too. Today, we're talking about something called radians. We've been just exploring the unit circle. Radian is defined by the arc of the circle. It's just another way to measure the angle. So we're really good with degrees. Degrees have numbers. They have what? Exactly. Radians are measured with pi. They're measured with what? Perfect. Let's get started. So let's say I have a degree, but I want to rewrite the measure as radians instead. I have the numbers here. To take any degree and convert it into radians, simply multiply by pi over 180. Really easy to do. You can use a calculator. You can make this one a fraction and kind of cross cancel. I can tell that this is 1/2. So 1/2 times pi is going to give me pi over 2. 90 degrees is the same thing as pi over 2 radians. They're two different measures. Let's do one more quick one. This time we've got 120 degrees. To convert it to radians, I'm going to multiply by pi over 180. If I make this one a fraction and maybe I don't have a calculator, I could simply multiply the numerators together and multiply the denominators together. But this is not an acceptable answer. We always want to reduce the fraction as much as possible. So right here, I know 12 over 18 would reduce to 2 over 3. So this is 2 pi over 3 radians. Same as the measure of a 120 degree angle. So 120 is the same as 2 pi over 3. Let's go ahead and fill out our unit circle using radians. Would you like a nice unit circle like this one? I'm gonna send a link in with this assignment. So if you do have a printer at home, you could print this out and maybe it's easier to keep organized. If not, it's totally fine if you just draw it on your own. Okay, first, we're gonna start with the degrees. Boom! Next, let's add in all the coordinates. Shazam! All right, so we have the degrees and the coordinates. If you could do this from memory, from scratch, you're in a great place right now. The last detail is gonna be radians. Now, I know all of the degrees, so if I wanted to 17 times, I could take each degree and multiply by pi over 180. And that wouldn't take too long, but there are some cool patterns that show up here. Let's check a few of them out. Earlier we did 90 degrees and we found out that that was pi over 2 radians. It's 1 pi over 2 to go 90 degrees. So if I go 90 degrees again, that would be 2 pi over 2. Cool pattern. What if I go a third 90 degrees? That would be 3 pi over 2. Exactly. What if I go another 90 degrees? That would equal what? 4 pi over 2. Exactly. But I can't leave an answer like this. It's not simplified. So I always want to reduce or simplify the fractions as much as possible. The 2's would cancel here. So 180 degrees is just pi radians. Every time I go 90, it's 1 pi over 2. 2 pi over 2, 3 pi over 2, 4 pi over 2. Sometimes that's a little quicker than always having to multiply it out. This is the safe way to go and a way to check it. Let's look at another angle, 45 degrees. In radians, 45 degrees is pi over 4. So every chunk of 45, every slice of pi is 1 pi over 4. So this is 1 pi over 4 here. I go another 45 degrees, that would be 2 pi over 4, but it was already reduced for me. Nice. If I go another 45 degrees, that lands us at 3 pi over 4. And then finally another 45 degrees, that would be 4 pi over 4. I don't need to write these ones in because they're already there for me. They're already reduced, which is great. I checked this one, 3 pi over 4. It's in simplest form. We're good to go. Your job is to figure out the ones on the bottom. Finally, let's look at 30 degrees. 30 degrees is pi over 6 radians. You could check it by multiplying if you want. So every 30 degrees is 1 pi over 6. So let's go a second 30 degrees. That gives us 2 pi over 6. Another 30 degrees is 3 pi over 6. Didn't need to write it. Another 30 degrees, 4 pi over 6. Over here is 5 pi over 6. And then finally here would land me at 6 pi over 6. So again, this one was already there for me. Same with this one up at the top. But there's a couple I still need to change here. These two right here are not reduced to simplest terms. 2 over 6 is the same as 1 over 3. 1 pi over 3. 4 over 6 is the same as 2 pi over 3. So I have the radians written for us on the top half of the circle. Could you figure out what the radians are on the bottom half of the circle? That's the assignment for Tuesday. Should be pretty simple. Hit me up if you have any questions, and we'll see you next time.